Good morning, students. Today we'll start your chapter electrochemistry. Okay, we will discuss this chapter in parts, and let's start this chapter. Okay, the electrochemistry is the branch of science that deals with the chemical energy changes and electrical energy changes taking place in a redox reaction. Redox reaction, about which you have studied in your previous class, are the reactions in which oxidation and reduction reactions are taking place simultaneously. The species which is getting oxidized will be a good reducing agent, and the species which is getting reduced will be a good oxidizing agent. Now the setup to bring about these type of electrochemical changes is known as electrochemical cells. They are of two types, galvanic cells and electrolytic cells. Let us understand these two types of cells by taking examples. Suppose consider these reaction again. Suppose we are taking zinc rod and dipped it in a copper sulfate solution. Okay, what will happen? The beaker will become warmer. That is, a redox energy change is taking place spontaneously. It is a spontaneous change. This chemical energy of the reaction can be converted into electrical energy by using a suitable setup, which is known as galvanic cell. That is, galvanic cells are electrochemical cells which are spontaneous in nature. Now suppose we are consider an non-spontaneous reaction, that is molten NaCl. Taking molten NaCl, no redox change will take place. But if we supply electrical energy to this molten NaCl, the ions present in the molten NaCl, that is sodium ion and chloride ion, will start moving towards the oppositely charged electrode, where sodium ion will get reduced to sodium atom and chloride ion will get oxidized to chlorine atom. This type of change is known as primary change. It is the primary product of the reaction. Chlorine atom, two chlorine atom will combine together to form chlorine gas that will be discharged at anode, and this is known as secondary change. Now the product of the electrolysis are the oxidized and reduced form of the cation and anion present in the electrolyte when we are taking molten NaCl. But if we take aqueous solution of NaCl, there are two types of cation and two types of anion: sodium ion and hydrogen ion, and chloride ion and hydroxide ion. Now these ions in the solution will compete with each other, and the ion that have low discharge potential will be discharged at the electrode. Comparing these ions, hydrogen and sodium, hydrogen ion has lower discharge potential and will get converted to hydrogen atom at cathode. It's a primary change. Two hydrogen atom will combine together and form hydrogen gas, and it is a secondary change. Again, comparing chloride ion and hydroxide ion, chloride ion has low discharge potential and will get oxidized first. So chloride ion will lose electron to form chlorine atom. Two chlorine atom will combine and form chlorine gas at anode. Okay. Now, in an electrolytic reaction, how much substances will be liberated and how much electricity is to be supplied, this relationship was first studied by Michael Faraday. He put forward two hypotheses or two laws. Let's see that. Faraday's first law. It states that the amount of chemical reaction and hence the mass of any substance, mass or weight of any substance deposited or liberated at any electrode is directly proportional to charge or quantity of electricity passed through the electrolyte. That is, W is directly proportional to Q. Removing this proportionality sign, we get constant Z known as electrochemical equivalent of the substance. Now we know that charge is equal to current into time. Placing IT in place of Q, we have W equal to ZIT. Z will be, or electrochemical equivalent will be, equal to the amount of substance produced when 1 ampere current and is supplied for 1 second. Okay. So the electrochemical equivalent of a substance may be defined as the mass deposited when current of only 1 ampere is passed for 1 second. That is, the quantity of electricity is equal to 1 coulomb. Okay. Now let's see the second law. Faraday's second law of electrolysis. Taking example of, suppose silver nitrate solution and copper sulfate solution, we can take more electrolytes also. If we take electrolytes or electrochemical cell, different electrochemical cell containing different electrolytes, and connect them in series, then the mass of any substance deposited at the electrode will be directly proportional to its equivalent weight of the substance. Okay. That means it states that when same quantity of electricity is passed through the solution of different electrolytes connected in series, the masses of substance produced will be directly proportional to their equivalent weight. Okay. So we can write here, mass of silver deposited upon mass of copper deposited will be equal to equivalent weight of silver upon equivalent weight of copper. Now let's see the quantitative aspect of electrolysis. Considering again the same solution of electrolysis of molten NaCl. See here, one cation of sodium or one sodium ion will accept 1 electron to form 1 sodium atom. That means 1 electron produces 1 sodium atom, or we can say that 1 mole electron will produce 1 mole sodium, right? Similarly, chloride ion will lose 1 electron to form chlorine atom, or 2 chlorine atom to produce 1 mole chlorine gas. It have to lose 2 mole of electron. That is, 2 mole of electron will be lost to produce 1 mole of chlorine gas, right? Now charge carried by 1 mole electron will be equal to charge of electron into Avogadro number. Okay, charge of electron is 1.6 into 10 to the power minus 19 coulomb, and Avogadro number 6.022 into 10 to the power 23. This comes out to be 96487 coulombs. This amount of charge. This amount of charge is equal to 1 mole electron. 1 mole electron is equal to this amount of charge, and this is known as 1 Faraday. For convenience, we will use 96500 coulomb per mole of charge as 1 Faraday. Okay. Therefore, number of electron involved in the reaction will be equal to number of Faradays of electricity. That will be equal to N into 96500 coulomb charge, and it will produce 1 mole of substance. Understood? Now in terms of gram equivalent, 1 Faraday will deposit 1 gram equivalent of substance. Also, value of Z will be equal to equivalent weight of substance upon 96500. Okay, or equivalent weight is equal to Q by W by Q into 96500. That's all for today. Thanks.